This is Mrs. Upmore. I'm going to give you a little refresher on scientific notation and rounding. This goes with slides 21 and 22 in your notes if you are following along, if you want to take a look. So scientific notation is basically when we write a number times 10 to some exponent. Okay, and we use it for two reasons. One is that it's a much more efficient way of writing very large or very small numbers. You don't have to keep track of how many zeros you've written down. Secondly, we can use it in order to get good sig figs in a number, and we often will do that. Okay, so if you look at the example on the bottom of the screen here, I have 20 million, which is a large number, right? So I could write that all out, and I could make sure I count all my zeros and whatnot, or I could just take my decimal, walk it this way, and I can write it as 2.0 times 10 to the 7th. Okay, so I walked my decimal 7 times, so that's where that 7 comes from. This also gives me the ability to get two sig figs, which is kind of hard when you have a number like 20 million and you're thinking, I only can have two sig figs. How do I do that? This is how you do it. Okay, so the 0 here is significant because there's a decimal in the number and it comes after the 2. And this still means 20 million. Okay. So we've got an example here. How many sig figs are in 8.20 times 10 to the third kilogram? When you're looking at sig figs, just look at this part of the number. Do not move the decimal and do not look at the times 10 to the third. Okay, so 8.20 has 3 sig figs. The 8 and the 2 both count, of course. The 0 is also significant because there's a decimal in the number and it comes after non-zeros. So I have 3 sig figs. If I wanted to actually know what this number was, I would walk my decimal out 3 places and I see that I have 8,200 kilograms. So let's say that I calculated that, but I needed 3 sig figs instead of 2 or 4. So this is how I do that. I move my decimal and then I can actually drop this last 0 because its place is still held by that exponent. Okay, if you have a hard time remembering whether to move your decimal to the left or to the right, you're not sure which way to go, I think this is the easiest way to think about it. Large numbers will always have a positive exponent. Okay, so the exponent is this number. So our first example is 9 million. If I walk my decimal over this way, then I end up with 9 times 10 to the 6th. This 6, positive 6 here indicates that this is a really, really big number, which 9 million is. Okay, for my second example, I've got 8.23 times 10 to the 10th. So automatically, I already know this positive 10 here means this is a huge number. If I needed to actually move it into standard notation, then I'm going to take my decimal, I'm going to walk up this way 10 times, and I end up with this gigantic number. Okay? So positive goes with really big numbers. Negative exponents go with really small numbers. So if I get this, I calculate this measurement here, that's a tiny number, right? So when I am moving my decimal to put it into scientific notation, I'm going this direction. And my exponent here needs to be negative, and that indicates that this is an itty-bitty measurement. On my last example, again, I've got a negative exponent, so that tells me that this is a really, really, really small measurement. If I needed to write it in standard notation, I'm going to move my decimal this way so that it does turn into a really small number. Okay, so I hope that helps. Positive exponents, always really large numbers. Negative exponents, always really small numbers. Okay, this slide is actually not in your notes. Most of you usually are totally fine on rounding, but we wanted to go over it just to make sure everybody's on the same page. We're going to follow the same rules that you learned probably in elementary school. So if your number is a 5 or above, you're going to raise the digit after. If it is below a 5, you're going to leave the digit as is. Okay, usually we're rounding to get good sig figs. So if we look at our examples here, let's say we measure 537, but we can only have 2 sig figs. Well, we're going to kind of block off the 2 that we know we need, and then we're going to look to the one just to the right of that. So 7 is larger than 5, So I'm going to raise it. And so that 3 becomes a 4, and now 540 only has 2 sig figs. Let's say that I do 464 and I can only have 1 sig fig. Well, again, I'm just going to look at this digit right to the right of the sig fig that I need. 6 is above 5, so I'm going to raise the 4 to a 5. And so I can get 500, which only has 1 sig fig. That's what I needed. You might be thinking 464 is really different than 500. Like, we just rounded a ton. But if you think about it, if you can only have 1 sig fig in your number, then you had a poor tool to measure, right? You weren't able to measure very precisely. So this is actually okay to round that much. A single sig fig probably means that you are guessing or eyeballing it, honestly. Okay, so it is okay to round that much when you only have 1 sig fig. Okay, so how would you round 567 to 2 sig figs? Well, we know we need these two. We're going to look at just the 7, right? We're going to look at just the number directly to the right of the sig fig we needed. It is above 5, so we're going to raise the 6, and so that gives us 570, and that gives me 2 sig figs, and I'm in good shape. Real quick, I do want to mention sometimes I have students turn 567 into 56 to get 2 sig figs. I just dropped the third number. Don't do that. 56 is vastly different than 567. You cannot just drop it. You do need to hold the place with a 0. So the 0 is not significant if we're counting significant figures, but it is important in place holding to give us the scale of the number. Okay, so I hope that helps. If you've got questions about rounding or scientific notation or sig figs, please reach out to your teacher.